We often take glass for granted, perhaps because we usually look through it rather than at it. Glass has enabled the development of contemporary civilization. It brings light into homes while keeping the weather out. We see it in art, where glass has long been thought of as aesthetically pleasing due to the way it can be colored and how its translucency catches the eye. Its resistance to corrosion means that stained glass windows have adorned churches for centuries. Eyeglasses have corrected deteriorating sight since the 13th century. But today, more than 1 billion people around the world have untreated vision problems, costing the global economy $200 billion annually due to lost productivity. All this could be remedied by initiatives supplying low-cost glasses. Glass is such a central part of our everyday lives, and we often don't even notice it. It's a high-tech transparent material that is protective, scratch-resistant, and tough, all while adding function. It can bend light in our microscopes and telescopes, teaching us how the universe and life has evolved. We are celebrating 30 years of the Hubble telescope. Without it and its enormous glass mirrors, we wouldn't have seen the beginnings of time and the formation of the universe. Now, thanks to glass, large Earth-based telescopes can see just as far. The 2020 Nobel Prize for Physics was awarded for the discovery of a black hole at the center of our galaxy. Reinhard Genzel and Andrea Ghez discovered this by tracking the movement of over 4 million solar masses, all packed together in a region of space that is no larger than our solar system. This was only possible using Hubble's giant glass mirrors that enable the collection of light over incredibly long distances. 2021 sees the launch of the James Webb Space Telescope. It will be 100 times more powerful than the Hubble and be able to peer back in time over 13.5 billion years to see the first galaxies born after the Big Bang. Glass now harvests energy, connects us through high-speed fibers, the hidden ultrastructure of the internet, and delivers unique medical treatments. All this while being one of the most recyclable materials. We are now in the glass age. So, what is glass, and what makes it so amazing? Let's start with a trip to the beach. It all starts with this: a grain of sand. Clean quartz sand, the most abundant raw material on Earth, is melted at temperatures hotter than the hottest lava. It is then cooled quickly, with some additives to help lower melting points, reducing the energy needed to melt. These additives also add important properties, from color to strength. What makes glass so useful is the random arrangement of its silica units. This lets us play with its structure and put other active elements in it. Those additives are also found near the beach, in cliffs, or in lake beds. An important additive is actually glass itself. Glass is 100% recyclable, adding value to itself by making production cheaper. Glass is the only material that can be infinitely recycled. In Europe, 74% of it is already, while CO2 emissions in glass making have been reduced by 70% and energy requirements by 80% over the last 40 years. Glass can also help reduce energy waste and generate renewable energy. Green glass can even be upcycled to hydrophobic glass particles, which replace sand in water treatment. These particles can then remove unwanted heavy metals, organic matter, and microplastics from water. Glass has been used to preserve food and beverages for centuries and is becoming more popular again due to the impact of plastic waste on landfill and our oceans. Glass is also the only widely used packaging material classified as generally recognized as safe by regulatory bodies. Common home insulation is made up of fine glass fibers that trap air, reducing heat flow in and out of our homes. Insulation can be improved even further by aerogel, a glass that is the world's best insulator. It is also the world's lightest 3D material, being 99.9% air. Aerogel was developed by NASA to capture meteorites and bring them safely back to Earth for examination. The space dust crashes into the sponge-like glass, getting lodged inside the structure. The aerogel's insulating properties protect the meteorites as the probe re-enters the Earth's atmosphere, leaving the meteorites undamaged, ready for analysis. Aerogel is also used in spacesuits, innovative clothing, and insulation for modern buildings, with engineers bringing manufacturing costs down. Speaking of modern buildings, glass is now fashionable. Thanks to the float glass manufacturing process, we can now make large flat sheets of glass, which are great for maximizing daylight, boosting well-being, and reducing the need for artificial light. But the glass also takes an important role in the ecosystem of vertical cities. Glass has always been able to filter much of harmful UV radiation. Now, modern glass also reduces the greenhouse effect for buildings by reflecting infrared light and regulating visible light transmission, and can be embedded with photovoltaic solar cells that harvest energy from the sun. You might think cleaning the windows of the world's tallest buildings would never end, but self-cleaning technology, glass coatings that break down dirt, keeps them clean. Special coatings on the windows interact with sunlight to actively break down dirt through a process called photocatalysis. It's true that tall buildings can be a danger to birds, but glass can help here too. Birds see UV light, so a patterned UV reflecting coating makes glass visible to birds while remaining transparent to human eyes. Solar power is no longer limited to low power cells. Solar thermal energy harvesting uses fields of glass mirrors to focus light and heat onto a central tower. The tower contains salts that store this energy and allow the continual release of steam. This can then drive turbines and produce electricity even after the sun has stopped shining. As it's 100% recyclable, glass keeps packaging out of landfill and reduces the need for new raw materials. Travel is now safer thanks to innovations in glass. Car windshields no longer shatter upon impact. Glass fibers give high strength to tough composites, from tennis rackets to wind turbine blades and lightweight aeroplane fuselages. There is also a vast network of glass fibers that connect the world. enabling reliable, rapid communication and transfer of data, bringing us the World Wide Web. The Internet allows instant transfer of information globally, from video streaming to the delivery of life-saving surgery from the other side of the world. Glass fiber communications have enabled us to communicate and carry on while in lockdown due to the COVID-19 pandemic. This experience has changed the way we work and is reducing travel, emissions, and fostering smaller carbon footprints. Our phones now provide global communication and bring media instantly to isolated populations across the world. Thanks to glass, screens are now scratch-resistant and even waterproof. Glass is the key to the delivery of 5G. The power of the radio signal is provided by a tight network of transmitters connected by high-speed optical fibers. Communications technology is playing an increasing role in the education of students, enabling information to reach far from existing institutions. This enables not only distance learning, but also communication for consumers and tradespeople in remote locations, keeping them in touch with the wider economy. Glass is a key material in healthcare, as it is one of the most inert materials in the world. It is used to carry and store sensitive drugs that could otherwise react with the vial they are kept in. Life-saving EpiPens have to be administered within minutes for patients suffering severe allergic shock. Glass cartridges are needed to store the medicine in the pen, but conventional glass would break in 1 out of 10 applications due to the aggressive nature of the injection. The success of the EpiPen is due to chemically strengthened specialty glass. Chances of failure are now 1 in a million. The optical fibers used to drive the internet are also used in endoscopes for minimally invasive diagnosis or surgical procedures. In medicine, there's also a special type of glass that dissolves in the body, forming a bond with bone and actively stimulating healing. It is called bioglass, and it has even been shown to combat deep bone infections. 2021 is the 50th anniversary of the paper that announced bioglass to the world. It has helped more than 2 million patients heal bones that would not have healed on their own, and is now used in toothpaste that can repair teeth. Biodegradable glass scaffolds work like scaffolds for buildings. They provide platforms for the builders to walk onto to lay down bricks. In this case, the cells are the builders, laying down the building blocks of bone. The scaffold is then removed by the body as the bone grows. Similar glass is used to make devices that resemble cotton, which can heal wounds such as diabetic foot ulcers that have not healed under conventional treatment. The glass biodegrades quickly, and within weeks, the wound is healed. Finally, glass can also be used to produce surfaces that are not only easy to clean, but also actively kill bacteria that threaten to colonize our hospitals and care homes. As microbial resistance to antibiotics increases, this technology is becoming ever more relevant to saving lives. we are finding new applications for glass all the time. This is because adding small amounts of new elements can radically change its function from optical and thermal properties to bioactivity. Almost every element in the periodic table can give glass a new feature. Window glass is strengthened by small amounts of aluminium and magnesium. By adding boron, glass can become resistant to thermal shock. Glass is colored by elements, such as chromium for green and cobalt for blue. Silver or copper can create glass that kills bacteria. Mixing in rare earth elements such as neodymium, erbium, or cerium can create glass that gives lasers their power. And adding strontium to bioglass may help heal bone fractures in patients with osteoporosis. These are just a selection of the diverse ways glass has and continues to contribute to international development. Glass's unique structure is allowing itself to be thinner, stronger, more flexible, and more functional, while using raw materials and processes that are sustainable for our planet. Glass is improving the world's quality of life while providing a carbon-neutral, zero-waste materials cycle. Welcome to the age of glass.